Hey guys, it's Jeffrey here,
And it's Jeremy Tian.
and we're the creators of Math and Dragons.
Hope you enjoy our game. As you can tell by the title of our game, it's a spin-off of a very popular game called Puzzles and Dragons. As many of you guys may or may not know, Puzzles and Dragons is a strategic game that has many levels, eventually culminating in a boss battle.
We chose this game because the user has to defeat many levels of enemy dragons while also solving difficult and challenging puzzles. However, instead of having the user solve puzzles, we decided to have the user solve basic trig functions.
In addition, as you guys may have noticed, the layout of our game is actually really similar to the game Pokemon. We realized that a lot of students taking trigonometry do not have these basic principles down. So we realized that it would be a great help if we could use a game to reinforce these basic trigonometric principles. Because trigonometry is so fundamental and basic and necessary to advance onto future maths, we realized that it is essential for students like these to focus more on these essential skills.
Therefore, we want to help students our age solidify their trigonometric concepts and have fun at the same time. Here are some monsters and dragons we use for the game.
And here are the background images that we use for the game as well.
When we first run the program, this screen will appear. This is our start panel. As you can see, here we have the title of our game, Math and Dragons. The creators, me and Jeremy. And on the right-hand side, you can see two J buttons. One says start, one says instructions. If we click the instructions button, a list of all the instructions will appear.
There's 10 levels for this game. And the first level, the enemy dragon has 10 health, and the next level, the enemy dragon has 20 health. And this goes on until we finally reach the last level, in which the boss dragon has 100 health. Now, each time you can either decide to attack or heal, and your attack will do 30 damage, and the heal will add 20 HP to your health. However, you can only use heal 5 times. And each round, the enemy dragon will do 10 damage to you if they are not dead. However, each time you want to heal or attack, you will be prompted with a trigonometric question, such as sine of 45. Then you will be given 4 choices to answer the question, and all you have to do is select the answer that you think is right and hit submit. You have 20 seconds to answer each question. If you answer it right, you will be able to attack or heal. Good luck!
When the start button is clicked, we come to our actual game. It starts off at level 1, which is shown at the top left corner. The user's dragon will be at the bottom left corner. It starts out with a health of 100. The enemy dragon will be in the top right corner. It'll start out with a health of 10 because it's level 1. And next to our dragon, we can see 2 buttons. One is for attack, and one is for heal. Like, if you want to pick attack, you would do 30 damage to the enemy dragon. But if you pick heal, your health will go up by 20.
Okay, now I'll just play through a couple of levels so you guys can see what the game is like. So first, I'll attack, and tangent of 90 is no solution. So notice how that we are on level 2 now, and that the monster has changed and it is now at 20 health. Now I will attack again, and cosine of 180 is -1. And now notice that we are on to level 3, and the background has changed and the dragon has changed. And I will try to attack again. And sine of 270 we know is -1. So now we move on to level 4, so the enemy has 40 health, and the background has changed as well. Now we're going to show the basic code for our game panel and its background images. So first of all, this is in the paint component of the game panel. And we have here where we all initialize all our images for our enemies and our backgrounds. And here we have a variable that's an int that's called count, which we first initialize as 1 in the constructor. And then we increment it each time we beat the enemy dragon. So at first, when count equals 1, then we have the level 1 background, and we have the level 1 enemy image. Now when we beat that dragon, we increment it to 2, so when count equals 2, then we call repaint, and then we will, as a result, have a different background and also a different enemy. And this continues all the way until we have level 10, and then we have the ultimate level 10 background, and we have the level 10 enemy image.
Notice how when attack or heal is clicked, a random trig question appears and it's 4 possible answers made by J radio buttons. Off, we have 2 final arrays, string arrays, and in the first one is called questions, and it contains all the possible trig questions that can be randomly generated to be shown on the game panel. And our second array is called answers, and it contains all the possible answers for each question. And notice how all the question and answers are correspond to each other in the similar indexes of each other. So we're going to be using these 2 arrays later on in our make questions panel. Okay, so we use math.random to generate a random array index out of all of them, and then our question becomes the random question in the array, and we use a decider math.random. It's also int, and we use this to generate the answers. So if decider equals 1, that means radio button 1 will contain the right answer. If decider equals 2, radio button 2 will contain the right answer, and so on and so forth. And we use this to create all our J radio buttons and display them onto the screen.
Okay, now we'll be talking about the teaching component of our game. So you see, if we attack, and then so the question is sign up 30, right? And if we say get it wrong, say we think it's 1, and submit. And it shows us here that we have, it gives us a diagram of the unit circle, which is labeled clearly about which angle is which, and which points correspond to which point on the unit circle. Now, we went a step further, and then we included a vector and an arc that clearly points out which angle that the question was referring to. And we also included an explanation on the side and a hint that says in order to find sign, look at the y coordinate of the ordered pair. And this explanation is customized each time based on the question that we get wrong. Okay, and now to show the code behind our teaching component. So just to give you guys some background, this is in the paint component of our question panel, actually. And we have this Boolean called time to teach, which we set as true whenever the user gets a question wrong. Now, basically, we use some string to int parsing, and also the substring method in order to basically extract the question, extract the angle, which in the previous case was 330, from the question and turn it into an integer. And now on the unit circle diagram, we will draw this arc of the angle that we extracted from the question above. And so as a result, that will create a unit circle diagram with the indicated angle using the special arc that we just drew in. And also for our explanation, we also used a couple of other pretty clever string methods that customize the explanation each time in order to show the correct question and the correct answer. And also we found out if the question had sign, then we printed this explanation for sine, and same for cosine and tangent. We each had respective explanations for each of those functions.
So as some of you guys may have noticed, the user only gets 20 seconds to answer each question. This is made using the timer class. Okay, so at the end of the 20 seconds, the user will not have any more time to answer the question, and whatever answer he has is his final answer. If he does not have anything, then the answer is incorrect, as shown here, and we'll go to the teaching component. Okay, so now we also use timer for the for our attack, which is the ice ball, and here you see we have the ice ball traveling across the screen, and so this is also made using timer. So every 1 millisecond, we call action performed, and we move the fireball across the screen. Oh, also, heal is also made using a timer, but we have a heart, like a healing heart, traveling upwards to represent like being healed, as shown on the left of the screen. And it just every 1 millisecond, action performed is called, and the heart will move up.
So here's our code for our timers. We first obviously declare our timers. This is the timer for the time limit on the user for answering the questions. This is the timer on that controls the movement of the ice ball, and this is the timer that controls the movement of the heel. Now, when we go down, we see here that we instantiate these. This is 1,000 milliseconds. This is 1 millisecond, and this is 1 millisecond. This means that every 1,000 milliseconds, a new timer event will occur. Now, if we scroll down to our timer handler methods, we have our first timer handler method, which is for the time limit on the user when he is answering the questions. So whenever this handler method is called, which is every 1 second, we decrement the counter, which is how many seconds they have left, and then update the J label that displays this. And when the count equals 0, then we check the answers as shown here. And in this timer handler is for the attack ice ball animation, and it is called every millisecond. And so every millisecond, the x coordinate is incremented by 10, and the y coordinate is decremented by 6, which gives the sense that the ice ball is actually moving. And we obviously call repaint to repaint the ice ball in the new location. And at the bottom we have the handler for the heel animation. So this also gets called every millisecond, and because it only rises up, the y coordinate of the heel picture is decremented by 2 every millisecond, and repaint is called in order to show the movement of the heel animation. Throughout the entire coding of the game, we constantly referred back to our target audience, students taking trigonometry, because they conveniently happen to be a lot of the students our age in our grade. Our target audience constantly provided feedback regarding how we should create our layout, which became what you see today. In addition, they were also very picky on what kind of images that we chose for our character and our enemy. Originally, many of the images that we chose had a background that seemed to stand out too much against the background image of the game. So our target audience advised us to remove this background of the image to make it seem like the monster belonged more in the actual game. In addition, we also referred to our mentor for a lot of feedback regarding the questions. Our mentor specifically told us to include choices instead of having the answer be an open text field. This way, he said, it causes the player to use more critical thinking skills to be able to eliminate the wrong answer choices in order to select the correct one. Alright, that's pretty much it for our presentation. Let's see if I can beat the game for you guys once. Alright, so tan 45 equals 1. Alright, on to level 9. Tangent of 225 is also 1. And as we were, just a side note, as we were testing with our target audience, it was funny to note that although people thought our game was really hard because of the time limit and it forced their mind to think about angles all around the circle, they still came back and continued to play, and it was really enjoyable just watching everyone. Let me think. Alright, that's our game. Thanks for watching.